All right, everybody. Today we are talking perpendicular lines. So go ahead and put that in your table of contents. Make sure you take your attendance quiz and take out your notebooks. Today is the 19th. All right, before we go ahead and talk about this new topic, let's review what we talked about on Friday. Go ahead and pause this video and decide who wrote the correct equation. All right, let's go ahead and see who did this correctly. First, we had this. We needed to write an equation that's parallel to y equals negative 3x plus 1. So first thing that I know by that is that if I'm parallel, that must mean that my slope is parallel. So my parallel slope is then negative 3. Well, Steve has that. Bruce has it. Tony didn't write it correctly. He made that a positive slope. But Peter did write it correctly. So those three have the correct slopes. Now we need to make sure that our point that we go through is 2, 6, where 2 is my x1, 6 is my y1. Well, let's see, did Steve do this correctly? Steve put in x plus 2, but we've said that if it's a positive 2 in the coordinate in my equation, it should be a negative 2. So Steve messed up there. So Steve is not right. So it's between Bruce and Peter. Well, Bruce did do x minus 2. Peter, on the other hand, was like Steve. He did not do x minus 2 like we wanted. So Peter didn't do it right either. But Bruce, if I check him on the last part, he's supposed to have a negative 6, and he does here, which means Bruce did do this correctly. All right, let's continue. All right, so now let's talk about this new topic of perpendicular lines. What are perpendicular lines? They're lines that intersect. They have opposite reciprocal slopes. In other words, what that means is that their slopes are flipped fractions with opposite signs. So for instance, if my first slope was 1/2, then my perpendicular slope, and that's, by the way, is the slope sign for perpendicular, is going to be negative, because I was positive, I'm going to flip to be negative, and then my fraction there is going to flip. Another example would be, well, if I had a slope of negative 3, my perpendicular slope would then be positive 1/3. So there's some examples. Make sure you get that definition and examples written down. All right, so are any of these perpendicular to y equals negative 5x plus 4? Well, let's look. If I want to be perpendicular, that means that my slope has to be the opposite reciprocal of my current slope. Well, I was negative, so I want to be positive. I was 5, and 5 is the same as 5 over 1, so flip that to be 1/5. So this first one here has a positive, but it's 5/4, so that's wrong. This one is a negative, so that's wrong. This slope here is in standard form, so I'm not sure if it's right, so let's move this negative 1/5. Move this 1/5 over so we can be in slope intercept. And I see I have a negative slope, which tells me that one's wrong too. This top one here, on the other hand, does have a positive slope, so that would be correct. The next one, they did not flip the sign, they did not flip the fraction, so neither are right. This one down here is in standard form as well, so let's add 1/5 x to both sides. We get y equals 4 plus 1/5 x. Positive 1/5 means, yes, this would be another example that is perpendicular. I would suggest writing both of those down as examples to being perpendicular to your original equation. All right, so on each of these, write a slope that is perpendicular to this equation. So we have to identify this current slope and then flip the flip the sign, flip the fraction. That's my current slope of 4/7. My perpendicular slope will be negative 4/7. Negative 7/4. My current slope is negative 3/5. So then my perpendicular slope is going to be positive 5/3. On this one, my slope is positive 8. So my perpendicular slope is going to be negative 1/8. All right, so just like Friday, sometimes you're going to be asked to write equations that are perpendicular to another equation and go through a point. Same thing as Friday. Identify your slope, but in this case, I have to make it perpendicular. So I was positive, now I'm going to be negative. I need to flip my fraction to be 2/3. I need to go through the point, negative 1/7. So y minus y1 equals m, x minus x1, negative 2/3, just go for m, x plus 1, y minus 7. Now let's distribute. I get y minus 7 equals negative 2/3 x minus 2/3. I'm going to add 7 to both sides, and I'm going to get y equals negative 2/3 x, and this is the same thing as 21/3. So 21 minus 2 is positive 19/3. And that's not an answer choice, but that should be the answer. All right, let's continue. Write an equation that goes through the point and is perpendicular to this equation. Pause the video and see if you can do this on your own. Okay, so I'm writing my equation, needs to go through that point and is perpendicular to this equation. So my slope is what I need to get first. There's my slope. My perpendicular would be negative 4/3. I need to go through this point. Y minus y1 equals m, x minus x1. My slope is negative 4/3. X minus 5, y minus 0. Since it just says to write an equation, that right there is it. I am done. Okay. All right, so write an equation that's perpendicular to the graph and goes through the point on the graph. Okay. Whenever you're given these, you need to find the slope first and then identify your points as well. So my slope of this line, I need 2 points to get it. Okay. I'm going to be rising 3, running 4. If I check to see if it's right, 1, 2, 3, 1, 2, 3, 4. That is right. So that means I have a slope of this line to be 3/4, but my perpendicular slope is going to be negative 4/3. I need to go through this point up here. Well, that point is 0,7. That then means I write my equation. Y minus 7 equals negative 4/3 x minus 0. If I wanted to get into slope intercept, I would continue on, but in this case, I don't have to.